just work with
At the
VMware?
moment, it only works with VirtualBox. They are working on integrating it with VMware Workstation.
Okay,
Yeah.
but no Hyper-V.
No, no Hyper-V or ESX.
Okay,
Yeah.
that's sad.
Yeah.
Because I got a Windows 8 client and I'm using the Hyper-V
Yeah.
on it, and it's pretty nice, but okay, I don't
Yeah.
have a live network Instagram.
Uh, yeah. Yeah. So I mean, that's the reason why I like using it. But the other thing is that
Ah,
the system has to be really powerful
yeah, that's a
and
good
all that
one.
stuff. Yeah.
Mhm.
But yeah, it's really good for that. Yeah, okay. So what we're discussing today, let's bring up the topic for today again. The topic that we're going to be discussing today um, is network services, which has to do with DNS and then VPN and routing services on Windows
Mm.
Server. So, and those are the things that we'll be discussing and focusing on today. So let's start first of all with a very interesting topic. DNS. And we're
Yeah.
gonna, yeah, so what we're gonna do is we're gonna go through exactly. So I've got the whole blueprint of 7411 in front of me. So we're just gonna go through the topics one after the other, and we'll see how far we go. DNS zones, DNS record, virtual private network, and then next week we do direct access. Okay. So where do we start from? Let's start with DNS.
Yeah.
So in 74 410 there is
Mm.
a module on DNS also. But
Yeah.
the module on DNS in this one goes a bit further than
Hmm.
the normal DNS module that we used in that we did in 7410. So
Yeah.
yeah. So the first thing is let's first describe like your understanding of DNS as a whole. What's your understanding of DNS? So who wants to start first? Jose, you want to start first. What's your understanding of DNS?
I just have a very basic understanding. Basically, it just resolves IP addresses to domain names
Yep,
and vice versa.
which one? So let's put that down, DNS. So Jose said DNS just resolves IP addresses to host names and vice versa. Yeah, okay. Any other thing? Integration.
I mean, I know you can do other things, but I don't know how to really explain it.
Yeah. Sven, any other thing that you like to add into DNS?
Yes, it's used for mail routing, for example, with the MX record.
Yeah. Yeah. It
This
does
is
the
one
same
point.
thing, but yeah, used for mail routing.
Yeah, this is an important one. Then you got service records. These are used for Active Directory, for example,
Yep.
LDAP,
Yep. Service record
Kerberos.
for Active Directory. I mean things
Yeah,
like
LDAP,
LDAP,
LDAP and Kerberos.
Kerberos. Yeah.
Um,
Anything else in terms of
um,
DNS?
well, you can use this for load balancing, DNS round robin, for example.
Mm, DNS load balancing or DNS. What did you say? DNS load balancing or round robin?
Then round robin.
Yeah.
Very basic, but you can do this.
Yeah. Yep.
And you can create aliases for a machine. For example, if you got a very large name for a machine, server one, you can just call him S1 or so. It's a
Yep.
more user-friendly name, for example.
Yep. Anything else? Taiwo, is there anything else that you want to add?
Mm, well,
Things that we mentioned regarding DNS.
yeah, well, nothing really. I just need it resolves It maps host names to IP address, uses like the fully qualified domain name.
Yeah, okay. Fully qualified domain name. Yeah, okay. So all these are like wonderful answers, and that's exactly the basic thing about DNS. It basically resolves, I mean, that's like its main purpose is to take IP addresses and translate them, sorry, names and translate them to IP addresses, or in the reverse, it takes IP addresses and transfers them back to names. So DNS as a whole, I mean, let's just go through it one after the other. DNS as a whole operates in an hierarchy. Sorry, the concept of domain namespace. So what's like your understanding of the concept of domain namespace?
Mm, I know like the .com. I mean like there's a root domain or something.
Good one, Taiwo.
Like the .com is the top level domain, and let's say like Microsoft.com. .com is like the top level domain, and Microsoft and that name is what's it called again? Uh, I know like the .com is the top level domain, and you can have
Just a minute.
subdomains on inside also.
Sorry, yeah. Just a minute, guys. Yeah, carry on, Taiwo. Carry on.
Yeah, it's like for instance, for my understanding is for let's if we use Microsoft.com, like the .com is the top level domain, and the Microsoft is I can't remember the name, or you can create also subdomains, maybe like
Yeah,
uh
subdomains. Yeah, carry on. Carry on.
yeah, you can create like subdomain like maybe Taiwo.microsoft.com
Yep.
and things. Yeah. I can't remember that middle one. I know there's top level. There is forgotten the middle one name.
Yep.
Yeah, something like that. Yeah.
Okay. Yep. Anything else? Ozzy, do you have anything that you want to add to what I was mentioned? So the domain
Yeah,
namespace, I would say there's a root domain, there's a top level domain, there are subdomains.
yeah. I don't know if this is correct, but break they break things up into zones. There's a primary zone, secondary zone, but I'm not sure if that's related.
Yeah, we'll talk about that one also. Yeah.
Yeah,
Um,
this
yeah, you
is
can
more
slip it under
about.
the, you can slip it under. Thank you. And Sven, what about you? Got anything to add?
Yeah, this is the most important part of domains, I think. Of course, you can have a lot of records in every part of these domains,
Yeah.
but I think over the top level domain, if you are very strict, there's also this one. This is the dot. Oh, sorry.
Carry on. Sorry.
Something.
Carry on.
There's a dot. So after the DE or the .com, there normally is a dot. I think this is a root domain.
Yeah.
But normally it's you wouldn't type this. It's just yes, it's just a dot.
Yeah. Good
And
one.
in every part of the domain, you've got different records.
Yeah.
And for every part of the domain, you've got responsible DNS servers. So there are DNS servers that are responsible for the .com domain, and there are DNS servers that are responsible for the Microsoft domain.
Mhm.
And so it's some sort of distributed. It's a distributed namespace. It's a distributed database. Not every domain, not every DNS server has to know every host record. This would be just too much. It's a distributed
Yeah.
database.
Yeah. Actually, those are like really all what you've said. I mean, exactly what I would describe there is exactly really accurate. So what Microsoft wants us to know in this module is number one, DNS is a service. Um, and again, it operates in a client server architecture. And it's a service that translates. Yep, and it's a service that translates IP addresses to. Sorry, I keep saying IP addresses. It's a service that translates host names to IP addresses. And the other thing they want us to know is that DNS is the main service responsible for name resolution in a Microsoft domain and also on the internet. Yeah. So that's the thing that they want us to know. So DNS is a service. It's a client-server architecture. So what do they mean by that? You have a client and you have a server. You have your client here, you have your server here. Inside your Windows client machine, there's an agent. The agent is called the DNS resolver. That's the name of the agent. The agent is called the DNS resolver. And you have your DNS server here. And your DNS server, breaking it down, simply put, it's a database. And what's a database? A database stores data. So inside that database, no problems, man. Inside that database, you find something like name DC1 equals to 192.168.1.1. That's what you find. That's the kind of similar things that you find inside that database. So you have your DNS resolver inside your client. So when you go to the web browser and type www.yahoo.com, when you type .yahoo.com, what your web browser will do is it will hand over that request to the DNS resolver, which is sort of like an agent within your client. So whether you're using Outlook, if you're using Outlook and you want to connect to a mail server, maybe you want to connect to mail.google.com, your Outlook client will hand over that request to the DNS resolver. So it's the DNS resolver's job to formulate something that is called a query. So your DNS resolver will formulate a query, and the query will be something like this. I'm looking for, I have DC1. I'm looking for, its IP address. So that will be the query, the DNS query from the DNS resolver. Sends it over to the DNS server. And then when it sends it over to DNS server, the DNS server responds. So DNS server responds and says, okay, this is the IP address of what you're looking for. So this is like within your Windows domain. But as you've said, it's not only like the name resolution protocol or the main name resolution service for the Windows domain. It's also the main resolution service for the internet. So here's the next thing that we'll do. The next thing I would do is let's do this. Let's do it step by step. So we'll try to understand it more. So let's say this is our domain here. So inside this big domain that we have, we've got a client machine here. We got client machine 1, we got client machine 2, and in here we have a DNS server. So let's call this DNS 1, and then we'll call this client 1, and then we'll call this client 2. Okay, so what we want to do is, can someone describe the whole process? So you go step by step, one after the other. So what I want you to describe is the whole process that this machine will go through, that client 1 will go through. If client 1 wants to resolve, sorry, I'll mute Van again. If client 1 wants to resolve www.yahoo.com.
That was a revenge of last time, right?
Sorry?
That was your revenge of me muting you
No,
last time.
no, not at all. No. There's like a lot of the reason is because there's a lot of feedback. Is anyone getting that feedback too? Are you getting the feedback that's coming back? That's coming through the mic?
Okay.
Yeah, so that was the reason why. No, it's not because of that.
Yeah.
Yeah. So Francis, I'll share the ID and the password with you so you can connect to the server. So Taiwo, do you want to start with this? Do you want to start with this? So client one wants to access wants to get the IP address of www.yahoo.com. Can you describe the entire process? So let's put it here and say the internet is here. So this is the internet. This is our local network. This is the internet. So can you describe the whole process from the very beginning? So you go to your web browser on client one, you type in www.yahoo.com. What's the first thing that will happen?
Well, it will send a recursive query to the DNS server.
Okay, let's put it down. Remember that anything you mention, you need to explain to us. so so let's put it down. So Taiwo said,
It's recursive. I think it's recursive.
Taiwo said it will send a recursive query to the DNS server. So my first question will be this. Oze, do you agree with Taiwo? That's the first thing it will
I'm
do.
on actually the same boat. I don't know if it's a recursive or.
Oh yeah, I used to get
Oh, okay, yeah.
I get confused in that. I think I'm not sure. It's one of the two. I can't remember.
So let's say Taiwo is like 80% sure. Oze is not sure.
Oh,
Frank,
I think
carry on,
let
Taiwo.
me,
I can't
let me
say that
explain. I think it's the
I
other
can't
way
say
around.
It's the other way around. Which other way around?
Is it iterative?
iterative.
Yes, I can't pronounce it well, oh, but I think it's the other one.
So Taiwo wants to change his final answer. He wants to be a millionaire. Final answer. Final answer. Iterative, is that your final answer?
Yes, that's my final answer.
Iterative, okay.
Yep.
Sven,
Yes, that's my final answer. Yes,
And
okay.
then just to put it in
I'm sure.
layman's terms,
Yeah.
basically it checks the local cat DNS cache first. So
Who,
that's
who, who,
where.
who mentioned that? Is that Jose or Sven?
Yeah, me, Jose. Yep, Jose.
Yeah. So okay, let's put it again. So let's put Jose is now coming up with something else. Jose said, well, yeah, I've moved from I'm not sure. Now I think the first thing it does is it checks. What did you say it checks? Jose, what did you say it checks? You said it checks the
Local DNS cache to
local
see if
DNS.
your client has ever been to that
Okay.
domain.
Okay. Sven, what do you say? Do you agree?
I agree with the local DNS cache. I would also add the local DNS file, the host file.
Local. Okay. No, no, you can only have one answer. You can't have two. So is it
Uh,
host file or is it DNS cache?
Also, okay, okay, it doesn't. Okay, also first of all, he will check the local DNS cache.
Okay.
That's the first step.
Mm-hmm.
Yeah.
So
And
after,
the second,
yep.
yeah, the second step would be the host file, I think, the local host file. And the third step would be a recursive query to its first DNS server.
Yeah, okay. So Taiwo, do you want to change anything?
No, I think I'm okay with my answer. Yeah.
You're okay with your answer. So
Yeah,
actually,
because the iterative, I might be wrong. That's just it needs a definite answer, which is, do you know it, yes or no?
mhm.
Yes, I think I think I'm correct.
Okay. So actually, you're all really close. I know you all have an idea of like the things that you're saying, but actually, this is the correct answer. The one that Sven mentioned as number two is actually the number one thing that your computer will do. Your computer doesn't go, when you type in .yahoo.com, it doesn't go and say, let me check DNS first. It doesn't go to start looking for DNS. The first thing it does is it checks the local host file. That's the first thing it does. The local host file, which is under your C drive, Windows, System32, etc. Sorry, is it drivers?
Drivers, yes.
Yeah, drivers. So let's go drivers. Then on the drivers, we have etc. Then we'll see the host
Host.
file. So that's the first thing that it will check. Let's open this with Notepad. So it checks. Have you opened it? Yeah, here we go. So it checks this place and say, is there any record in here for www.yahoo.com? So let's do this. Let's go www.yahoo.com and let's go home. Let's go 8.8.8.8 just to play, just to play with this, and then let's save it. So let's save this, and then let's go to our computer and let's flush our DNS cache. How do I flush the DNS cache?
But I think we don't need to flush the DNS cache, right? Because he
Yeah, that's
looks
true.
in the right.
Thanks very much for
Because
that.
perhaps we can browse to Yahoo in the first place.
Yeah.
And
Let me see if this one will even. Let's see.
okay. Yeah.
No, cause it's if I go ping www.yahoo.com. Yeah, there you go.
Yeah.
So you
Yeah.
see, the first thing that it does is, hey, even though this is not www.yahoo.com, this is Google's DNS server.
Yeah.
But it's like, yeah, the first thing I'm doing is I don't care about DNS. I'm looking at the local host file. Is there any record in there? So that's one of the ways that people that hack applications that connect to the server. That's one of the things that they do. They go inside the host file, they change the name of the server that the application is trying to contact, they change it to the computer to bypass, checking the internet and all that stuff. Because this is the first thing that it checks. So does that help, Taiwo?
Yeah.
That the first thing that it does is the local host file. So after it checks the local host file, what's the next thing that it checks?
Well,
So let's go back to the diagram.
yeah.
So now we said the first thing this guy would do is say, hey, do I have www.yahoo.com in my local host file cache? In my local host file. If I have it, that's what I'll use. If I don't
Yeah.
have it, what will it do?
Then it will query the DNS server.
It will query the DNS server. Do you agree, Sven? Or
No, I think you should check the local DNS cache. Because if he got an answer in the past, he will use this answer.
So it says it checks the local DNS cache. Jose, what do you think?
Well, that's So I'm sorry. So it checks the local server cache. Is that what was said?
That after checking the host file, that's the first thing it does. It checks the host file. So after that, what will it do?
I mean, if it doesn't find it locally, then it'll go out to your DNS server to try to get a resolution.
DNS server, okay. So Jose says DNS server this time around. And that's the same thing that Taiwo and Jose said. Francis, do you have any comment on this? What's the second thing? So if it checks the local host file and doesn't find it, what's the next thing that it does? Let's see. Is Francis typing anything? Okay. Sorry. Let me post it for you again.
Yeah, sorry. I was joining from my phone, so I couldn't see anything.
No problem, sir. I'll send it to you again. Yes, I just sent it again.
Thank you.
Yeah. So Francis, do you have anything else that you want to add to that? So actually, this is right. The local DNS cache is the next thing it's going to check. So it checks to see, do I have this record in my local DNS cache? So the question is, how do I check my local DNS cache on this machine?
ipconfig.
ipconfig.
Yeah.
Display DNS or something.
Yeah,
Display DNS.
thanks very much for that. Thanks.
Display DNS.
So display DNS, and that
Yeah.
will show me my DNS cache. So the next thing it does is like, hey, do I have a cache of this already? And this command is so good. It will show you, it will even show you the time to leave for that particular record. So it's going to say, first thing, let me check my host file. Hey, if it's not there, let me check my local DNS cache if I already have this record. So if then it doesn't have the record, what's the next thing that it's going to do?
Well, it's the server now.
Yeah.
Oh, I'm still wrong.
What do you think? Who agrees or disagrees with Tayo?
So,
sure
so
if
isn't the host file and DNS cache sort of the same thing, or is it
No.
completely different?
No.
Yeah,
The
Sven,
host
you want to
file,
answer that? Yeah.
the host file is static. You can put static entries into the host file, and the DNS cache is generated dynamically. So if you browse the web, everything you're browsing will be filled into the local DNS cache. So that's the difference.
Okay.
Yeah, it's used for the client, so it doesn't have to make a lot of requests to the DNS server.
Yep.
Yeah, but do people still use that host file?
There may be reasons. Do you want to answer that question, Sven? Carry on.
Yeah, you can use it for debugging or so, yeah, or to modify. Yeah, you can modify your host records, for example. For example, in our company, we got a new load balancer for Exchange, and we wanted to redirect several clients to the new load balancer, but not the whole company. And so we used a modification of the local host file, for example.
Yeah.
So
Carry on,
do that
Taiwo.
manually, or is there somewhere you can do it via group policy or something?
You want to answer that, Sven?
You can modify it with PowerShell or scripts, and this script you can deploy via group policy. I don't know if you can modify the local host file via group policy directly, but you can do it with VB script or PowerShell.
Yeah.
Oh, okay.
Yeah, I agree. So I agree that one can do it through scripting, but I'm not sure also if one can do it via group policy. But I'm sure one can do it via scripting, PowerShell or VB script. But then the whole point is, if you want to bypass the DNS server for any reason, I mean, what do you think? Like, I mean, you guys have, well, even though it's recorded, but you guys, I'm sure, you've downloaded all these applications from Pirate Bay and where they will have this README file and tell you, direct Microsoft.com to 127.0.0.1.
Activate.com redirect to
Yeah, to
127.0.0.1.
127.0.0.1. Yeah, exactly. To avoid, because when the application starts up, the application tries to contact the server on the internet and check, is this user registered? Is the license valid? But because this one is first, so this one always wins. In any situation, any record in the host file always wins. So just be like, yeah, let's bypass that. Let's just go. Nice one. Congrats, Francis.
Well, I'm looking at my local host file on my machine. It's a Windows Vista machine, but it doesn't have much in there, so I'm not sure what would.
No, that's normal. That's normal behavior. Normally, it's empty. It's empty. And some tools like Spybot Search and Destroy put some entries in there to avoid surfing to malicious sites like, I don't know, badsite.com or so.
Yeah. So actually, Sven is right, because sometimes if the host file is typically empty, or even the entries that are there are already, commented out. But the thing is, some viruses really do go into your host file and make changes to it. And then in order to, like, maybe you want to go to yahoo.com and maybe a virus wants to redirect you to one of its other pages. So it will infect your computer and just put an entry for yahoo.com to its own IP address. And that one always wins because that's the first thing your computer will check. So your
Okay.
computer will be going to that location. Actually, what many antiviruses do nowadays is they monitor the host file of. I know the antivirus we use in my company monitors the host file. So one of the alerts we get is there's an host file entry that is not in the default on this computer. So we can check to see, hey, is somebody, is somebody trying to infect the system or something like that. So yeah, the next thing that it does, it just checks your DNS server. So it queries the DNS server. So yeah, next thing that this does. So now we've come to the part of number 3. We said local host file, local DNS cache. If not, DNS server. Hey, do you have this record? So what do you think will happen after that, Taiwo?
Oh,
So it queries DNS server.
if it has it, it will
What does the
give
DNS
it.
server do?
Yeah, it's just resolves host name to IP address.
Okay, so what do you think the DNS server would do once it receives the query? The query. So this server is saying, I need www.yahoo.com. Once your DNS server receives that query, what will your DNS server do with it first of all?
To check his records to see if it has it.
Taiwo said number 4, DNS server checks record. So who agrees, who disagrees? Jose, do
I
you
agree.
agree? Jose
Yeah, I
agrees.
agree.
Sven, what about you? Do you agree or disagree?
I think the DNS server checks its own DNS server cache first.
Right.
Because it could be that this DNS server has resolved www.yahoo.com in the past, and so when he has this answer already in the cache, he would give this answer back to the client.
Taiwo, do you want to change your answer? Or Jose?
No, well, I thought he meant exactly what was said. I thought, it is, if the DNS server cache, has it, then it'll respond back. But if not, then
Yeah. So the next thing actually, so Sven is right in that the next thing that will happen is once a query gets to the DNS server, it doesn't start to if it's a query for something that is not on the DNS server, the first thing that it does is checks its local cache. Do I have this record in my local cache? Have I resolved it before? So that's the next thing it does. Because if somebody else, let's say client 2, has put a query to DNS1 for yahoo.com before, and DNS1 has resolved it, I'll mute again, sorry. And DNS1 has resolved it. Somebody keeps sending me messages. Let me just quickly reply. Uh, let me just quickly reply, Carlos. Yeah. Okay. So the DNS server says, "Oh, I've resolved this. I'll store it in my cache." So there's a client cache, there's a server cache. So it stores it in its cache, and if client 1 now comes and says, "Hey, I want to go to yahoo.com," it looks and says, "Oh, I've already resolved yahoo.com before. So I'll just look in my cache. Oh, I have the IP address of yahoo.com. I'll just give it to you directly from my cache. I won't try to resolve it. I'll just give it to you from my cache." So that's the next thing it does, is it looks in its own cache. So if it doesn't find it in its own cache, then it does what? It begins the resolution process. So the next thing will be, who wants to describe the resolution process of this DNS server going out to the internet for us? Who wants to describe that?
so basically it will go out to the internet, look for an address.
What will it go out to on the internet? Which server will it go out to on the internet?
The DNS will go out to the internet DNS servers.
Which DNS? Yeah, exactly. So which DNS server? Which DNS server is it going to talk to?
Whatever it's set up in the root hints.
Good. You're bringing some very interesting points here. So let's write that down. It says root hints. So my question to you, because you brought this up, Jose, so you explain to us. So what are root hints? Wait, what does it mean when you say root hint?
Root hints are things, or I guess addresses. It's a good question. I'm not sure how to fully explain it.
Yeah. Who wants to help us there?
Well, I think they're just IP addresses of they're all scattered all over the internet that has almost DNS information on.
So IP addresses.
Well, there are servers which has information about most domain names and their information.
That have information about most domain names and their information.
You're writing me word for word.
Yeah, yeah, because there are some questions that we'll ask. Because once that, so can you explain to us what you mean by servers that have information about most domain names? What does that mean by servers that have
Well, I
information about
mean,
most domain
not.
names?
I think no. I know they are scattered all over the internet,
Yeah, they're
and
scattered all over the internet. Yeah.
there are a couple of servers. I think I can't remember how many, but yeah, that is how DNS gets online to resolve stuff. It goes through the rootkit servers.
Mm-hmm.
I think these root servers know which DNS servers are authoritative for the top level domains.
Okay, so Sven is saying something again. Sven says routing. He says they know which servers are authoritative for the top level domains, right?
Yeah, right.
Yep. So let's take this away for the top level domains. Okay. So let's try to describe this. Let's go to let's bring up our website. Let's go paste rootservers.org. Boom. Actually, I think there's 12 or 13 of them. Let's see. There's 12 or 13. So yeah, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 of them. So you look at root server A. This is the IPv4 address. This is the IPv6 address. The servers are located in New York, Los Angeles, London, Hong Kong, and Frankfurt. And the person that is hosting it, or the company that is hosting it, is VeriSign. Then there's root server B. The person or the operator or the person hosting it is Information Sciences Institute. And it only has one site in Los Angeles, USA, and that's the IP address. Then there's root server C, Cogent Communications. It's in 8 sites, Paris, New York, Madrid, Frankfurt, and that's the IP address. So if I go, let's go to this one. Let's go. Actually, my computer won't be able to resolve it, but let's go. They've got names that they call them. Yeah, no, sorry. Take this one out. You see, he said the 13 root name servers are operated by 12 independent organizations. So the organization, so this is the way it works. So let's go here. So actually, if I go to www.yahoo.com, like Taiwo said earlier, there's a dot at the end. There's an invisible dot at the end. If I go to www.yahoo.com and I press enter, it will take me to yahoo.com. But I don't have to put the dot because it will take, except it's still trying to resolve yahoo.com to 8.8.8.8. So I need to go change that one. Open with notepad. Yeah. I think I still have that record in there. Yeah.
You should also flush your cache.
Yeah, I should do that also. So I say, oh no, did I click don't save? Sorry. Open. Yeah, let's get rid of that completely. And let's save it. And let's go save. And then let's Yep, there we go. Now we're on yahoo.com. So I put dot at the end. It takes me to www.yahoo.com still. So the dots that's at the end, this is the way it works. You've got these servers all over the internet. There are 12 of them. Yeah. It's not as if they are just 12 servers. We read that they are like, so we have these servers. So let's just put 3, for example. So one would be like maybe root server hey. Root server hey, as we just saw, is hosted by VeriSign. And I think it has 5 locations around the world, or it's located in 5 sites. So what VeriSign will do is VeriSign will have, if you dig deep, what VeriSign will do is they will have 5 servers in those different locations. There could be multiple servers, more than I'm sure they will have more than 5 servers. So it'll be multiple servers in like one in Frankfurt, one in London. No, it won't be one. It'll be multiple in Frankfurt, multiple in London, multiple in Hong Kong, multiple in US, and things like that. But what will happen with them is you can see it has only one IP address. So they will probably have something like a global load balancer that the IP address that we just saw, this IP address for root server here, 198.41.0.4, this IP address is pointing to a global load balancer. And what this IP address will do is it will just distribute the traffic that is coming in based on your geographic location. So if you're from Asia, if you hit this address will just redirect your traffic. From this point, it will redirect it to the servers in Hong Kong. If you're from Europe, it will redirect your traffic to maybe Germany or London. If you're from America, it's going to redirect your traffic to the server in America. You get the point. And the information that is on them, what information do you? So actually, let's make it clearer again. Root server A, root server B, they all have exactly the same information. Every single one of them have exactly the same information. And what sort of information will you find on them? What do you think? Do you think you find something like let's see, you will probably find A records and AAA records, but mainly what sort of records do you think they'll have?
Well, I think it just points you to where you want to go.
Yeah, but there's a particular type of record that they will have.
It's not pointer.
NS records. What are NS records? What are NS records? Sven or Jose, what are NS records?
I'm thinking about it.
It's a record for DNS servers, and these DNS servers are authoritative for the soup.
A good answer. Very good answer, Sven. NS record, it's a record that points to DNS server that is authoritative for a zone. So what does that mean? Let's break that down so that it won't be confusing. We have top-level domains like .com. We have top-level domains like .co. What this one will do, because it's not going to be pointing to, this is www.yahoo.com or this is www.google.com. It won't be pointing to that. What it's going to be pointing to, you say, I have an ANS record. Yeah. And the NS record is for .com. And the DNS servers that are authoritative for .com, they are 198.1.1.1 and 198.1.1.2. So it will just be something like that. You'll be like .co. There's an NS record for .co. And .co's NS record, the servers that are authoritative for .co are 198.3.3.3. So it doesn't know anything about Yahoo. It doesn't know anything about Google or Microsoft or anything. The only thing it knows about are what Taiwo mentioned earlier, the top level domains. So it's like the only information I know are information of the name servers for the top level domains. I only have the information for which DNS servers can resolve these domains. That's the only thing I've got. And actually, it's something that you can download on the internet. Actually, you can actually download the record that's on the record that's on the root servers. You can actually download it on the internet. Let me see. I think I've got, yeah, okay, yeah, you can actually download it from Hana's website on the internet, and you see exactly what the record is like that is on these servers. So let's go to that website. Yeah, so you see we've got, again, remember DNS is only a database. Its DNS server is only a database. So we've got domain root database. So you can see something like, okay, we'll come to this one, but this is not actually the one I'm looking for, but we'll come to this one because this one is also really important and it can also be helpful. But we'll come back to this one. So it's not the one. Let's see. Root zone database download. Let's see. Root it int file. Yeah, here we go. Root zone file. So I think this one will just be root int. I think this one will be the root zone file. So let's see. Yeah, here we go. Okay, so this one is the one that tells you what the root servers are. So a root servers.net, which is the one that is hosted by VeriSign, is pointing to this global load balancer, which redirects it to the different sites that VeriSign has them. And you have B, and you have them up to 13, which is M. Let's see the other one. Yeah, okay. It doesn't, but there's a place that I saw that where you can actually download the actual database that's on those servers themselves. And basically what you see there will be something like this. You see NS record for .abogado. You see NS record for .ac. You see NS record for .academy. You see NS record for .accountant. You see NS record for .active. NS record are the name servers or the DNS servers that can resolve these domain names. And it's telling you that the organization that is responsible that hosts DNS servers that can resolve this domain name is this organization. So they are the ones that have the servers that can resolve this domain name. I'm not sure if that is clear. Is that clear at all?
Yeah. What's NS stand for? It's just
name server. Yeah.
Name server. Okay.
Yeah. It just means name server record. That's all. Taiwo, is that clear at all? Is that helpful?
What of .com?
So .com is actually, that's a good question. What do you think is hosting the servers for .com? I think it's VeriSign or something. I think it's probably VeriSign. Yeah, there we go. It's VeriSign. So .com servers, they are hosted by VeriSign.
Right.
So
Okay.
the server, so basically if you look on the internet, what you find are these. You find these root servers here. Then under that, you find VeriSign will have DNS servers that are hosting .com. So anybody that has not www.yahoo.com, maybe something like Yahoo, the name server record that can resolve Yahoo, that will be on there. The name server record that can resolve Google, that will be on there. The name server record that can resolve Microsoft, that will be on there. And they'll have lots of servers around the world, and the company responsible for them is VeriSign. The same thing .ac. There's a company that's responsible for them. .co. This company is responsible for .co. .cn. This company is responsible for .cn. They are the ones hosting the servers for that. And the way it works is they keep going down that way. They keep breaking it down. So when you get to .com or maybe .co under it will have .uk because you have .co.uk, right? Oh, sorry.
Yeah.
Oh, sorry. not that way. You have .uk down. .uk should be down here. So actually, there will be a company that is hosting .uk. So under .uk, there will be another server for .co. There will be another company. Well, maybe not, but there will probably be a company that is responsible for hosting .ac under .uk. There will be another company that is responsible for hosting .co under .uk. I'm not sure if you're getting the point. So it's actually like all these companies coming together, hosting different servers. It's not as if it's the government that's hosting them. It's independent companies that are hosting them.
So
Anyone
what do
have
we
a
call these .support.com? What do we call those? Namespaces or?
No, it's .com. Hello? Hello.
Hey, you're breaking up. I'm
Yeah,
sorry.
sorry. Yeah. Can you repeat the question? Sorry.
Yeah, I was just saying, what do we call these? Like .net, .com, .navy? What are those? Just namespaces or what do we call that?
They are
That's
named.
a top level.
Carry on, Sven. Sorry. Carry on, Sven. Sorry.
That are the top level domains.
Yeah, exactly. So they are called top level domains. So that's what they are called. So again, let's
Okay.
look back at this diagram. Let's first look at this information that Taiwo mentioned at the beginning. We have the root domains, and we've established that this root domain, it's basically servers on the internet that have the same database. And there's 13 of them hosted by different companies. And those different companies have different sites where they've put the servers. And they have global load balancers that they're using to redirect traffic to the different sites that they have. And they all have exactly the same information. So if something were to take out the whole of VeriSign servers, there will still be another company that have got the same servers all around the world. And if something were to take out that whole company, there will still be another company that's got the same information and the same servers all around the world. And yeah, and they are all independently managed. They're not managed by government. So those ones will only have name server records for the top level domains. The top level domains, so this one is probably not too accurate. So let's end that one. So subdomains would be something like Microsoft or something like Yahoo. So top level domains like .com, they also have companies that are responsible for them. Like .com, VeriSign is responsible for .com. So under .com, what you find are name server records for these subdomains. So under subdomains, you still have second level domains. So you get. I'm not sure if you get the point. Taiwo,
Yes,
is
much
that
better
clear?
now.
Taiwo, do you have any question regarding that? I want to try to make this one
No.
really, really clear. So we have a clearer
See,
idea of what
see,
root
see, I
servers are.
get the top level domain. I'm just a little fuzzy about the root domain. Sorry.
Yeah. So actually, let's go to one of our servers. Let's go to this one. So if I go to, let's log into this one. Hopefully, I still remember the password. Okay, I think I remember it. Yeah. Okay. Then let's go. I think I've got DNS open somewhere. Maybe not. Let's open DNS on this server and let's see something. DNS. So under DNS, so every operating system or anything that you buy that has to do DNS resolution will usually come with the root int record installed on it. So if I go under properties here, and you see other root int here, it's the same information that you find on this website, and the same information that you can download. This same information here, 198.41.0.4 is a rootservers.net. And if you go back to that, that's exactly what you find there. So it's 198.41.0.4 is a rootservers.net. And B, so this one, VeriSign is responsible for it. This one, another company is responsible for it. And that's basically what your DNS servers will go and say, hey, so back to what we were discussing earlier. So there'll be, let's represent it just with a single server and let's call it root. And let's call it root. So your DNS server will go out to the root and say, hey, I've got this record for www.yahoo.com that somebody is asking me. So it goes to talk to the very root. So DNS resolution takes place from right to left. So start from the dot. So if you go www.yahoo.com dot, so your DNS server will go straight to the dot, which is the root, and say to the root, hey root, I need to resolve this record for www.yahoo.com. So what do you think will happen after this one? So when your DNS server goes to talk to the root, what will happen?
I think the root will say, okay, you're looking for a .com address. I know the DNS servers that are authoritative for the .com domain,
Yep.
and here are the IP addresses,
Yep.
and afterwards the DNS one will ask one of these IP addresses. Yeah.
Good one. Yes, good one. And basically, so it will go and say, hey, root, whether it's the VeriSign one, whether it's A or B or C or D or M, it doesn't matter. They all have the same record. It will say, I've got www.yahoo.com to resolve. What have you got for me? Root will go, yeah, I don't know the answer to that, but I know the servers that are authoritative for .com. How come it has that information for servers that are authoritative for .com? Because that is what is on its database. That's all it has. All it has is I have a NS record for .com, not a NS record. It will be multiple NS records. I have NS records for .co. So that's all it knows about. It doesn't know about Yahoo. So it's like I know I have a NS record for .de. I have a NS record for .ac. So I have all these NS records that I know about. So I'll give you the name server record for .com for one of them. So under this one, you have the .com servers here. So maybe there's one here for .com, maybe there's one here for .co, maybe there's one here for .de. There'll be lots of them, and this one will go .com. So again, .com is hosted by who? VeriSign. .de will be hosted by some other company. .ac will be hosted by some other company. And this company, what will happen is when this company, maybe they have another new server that they just installed in China. So they installed this new server in China that has all the record for .ac. They will send an email. There's an email that you send an email to root@ayana.something. You send an email to them, and they will send an email out to all the people that are handling the root servers to VeriSign to this one and say, hey, there's a new server for .ac. Can you add a NS record, for this server in your database? And they will add it. I'm not sure if you get the point. Yeah. So these guys that are handling .com, so VeriSign comes up and says, oh, let's make this thing even much more redundant. Let's have some servers in Antarctica. So we have these new servers for .com in Antarctica. They send an email to Ayana and say, hey, we've got this one. And I send an email to everyone and say, hey, the 13 guys hosting the roots, can you add a new NS record for .com for this new IP address? And that goes down to all of them. Is that clear, right?
Yeah.
Yeah, good one. So that's what happens. So it goes and says, well, I don't know about this, but I know about .com. So it does that. So this guy comes and this guy goes, okay, I go to ask.com and say, hey, do you know about www.yahoo.com? So Taiwo, what do you think .com will say to this guy?
Yeah. Yeah, it will tell him, well, I have information for Yahoo.
For Yahoo, what information will he have for Yahoo?
The IP address of
What sort of
the
record will it be?
name server record for Yahoo.
Exactly. So it will have the name server record for Yahoo. That's all it will have. So it will say, well, I don't know about this, but I have NS record for Yahoo. I have NS record for Google. I have NS record for this one. So all I know about are the subdomain records. That's all I know about. I don't know about anything else. If there's .uk.yahoo, I have no idea. I have no clue. The only thing I know is that there's a name server that can resolve anything that is Yahoo. So remember, it's going from right to left. So that's the way it's going. If www.uk.yahoo, it doesn't know about the UK, it just knows Yahoo. I know the server that is authoritative for Yahoo. So here's the name server record for that. You go talk to that DNS server and it can help you out. So this guy goes, okay, I can talk to Yahoo server. So this brings a good question. The other day I registered um I registered a record on the internet for lightbulb dot well I hope I won't make this too complicated, but I think it will help someone. For lightbulbit.co.uk, something like that. I just registered it for for fun. Lightbulbit.co.uk. So I registered it. It'll probably take you to google.com, I think. Yeah. So I registered it with GoDaddy. So I went to GoDaddy and said, "Hey, GoDaddy, can I register this new domain name? Is available, blah blah blah." They registered it for me for £3, I think. So after registering that, what do you think happened with that? What exactly happened? Does anyone want to describe what happened? Sven, what do you think happened? So when I went to GoDaddy, because this gets confusing to many people. I'll tell you something. People understand easily DNS in a local domain. But when it comes to the internet, it's a little blurry. It's a little confusing about what is going on. So what happened when I went to GoDaddy.com to register my domain? So the domain I registered again is lightbulbit.co.uk. So what do you think happened when I went to register this domain?
I think the DNS server that is authoritative for the CO domain
Yep.
updated its database with a new A record. And
.co domain, are you sure? Does anyone agree that it is .co domain?
I don't know. cu.uk is something special,
Yeah.
right?
I think it'll be .uk first,
Yeah.
right? Because it goes
So
from right to left.
it goes from right to left. Yeah. So under .co there'll be .uk. So under this one there'll be another server that is
Yeah,
available.
that's right. But I think the administrators of the UK domain doesn't have to do anything
Yep.
because nothing changes on their side because they just have to know, okay, for the CO domain,
Mhm.
there are these DNS servers authoritative,
Mhm.
and when you register Lightbulb IT,
Mhm.
just the administrators of the CO domain have to update their database with an A record, I think.
With an A record. Are you sure it's an A record?
Yeah, Lightbulb IT is
It'll be
which translates this DNS name into an IP address.
Taiwo, what do you think? Do you think it's an A record?
Well, if it's going to register, I know GoDaddy will create an A record for it, but if it's going to be registered, well, what I think is GoDaddy will create an A record for your domain. And once it's, you mean how it registers on the root hints?
So how for example now we mentioned this. What we've discussed so far, we said if you go to .com will have all the records for all the subdomains, right?
Yeah.
Like Yahoo. So now just register this name lightbulbit.co.uk. So now if we go to that and say we go from client one will go to root and say, root, I'm looking for lightbulb.co.uk. Root will say, I don't know about lightbulb, I know about .co. So it will reply. So this one will now go to .co and say, .co, I'm looking for lightbulbit.co.uk. .co will say, hey, I have no idea what lightbulb is, but I know where .uk is. So we'll say, okay, yes, .uk. So this one will go and say .uk, I'm looking for lightbulbit.co.uk. How will .uk know the name servers? Because there must be DNS servers that can resolve lightbulb IT.
So GoDaddy will create a SRV record first.
So where will they create that
GoDaddy.
record? On which DNS server?
GoDaddy would give you name servers. So GoDaddy would provide you name servers,
Yeah.
and then within those name servers, they will have a default. So if you create a domain or you purchase the name, they have default records, and there'll be www record and so on. So and then you have to manually go inside them and edit them to point to your website. So that might be hosted with a different company,
But what
or
I
it
mean
might
is
be
that
hosted.
how does .uk know about those servers?
from the name.
How does .uk know about the server that can resolve lightbulbit.co.uk? How does .uk know about that server? Because .uk is basically, it's basically some servers on the internet. So how does .uk know? Okay, hold on. If I'm looking for anything lightbulbit, this is the DNS server that I need to go talk to. How does it know that?
Or are they using canonical names?
Let's go here. Let's go launch. So this is the one that I registered the other day. So let's go down a bit and see what happens. Look at this. These are the name servers, two of them, that are hosting lightbulbit. So sorry, that lightbulbit that are hosting lightbulbit. These are the two of them. These are the two name servers. These two name servers belong to GoDaddy. So basically, the way it's going to work is GoDaddy will have these two servers, and these two servers, their names are, ns3.domaincontrol.com. So if I go nslookup, yeah, and that's the IP address for it, IPv4 address, the IPv6 address for it. So DNS, so GoToDaddy will have these two servers. So what GoToDaddy would, sorry, not GoToDaddy, GoDaddy. What GoDaddy will do is on this DNS server, they will go and create a new zone, and the new zone will be lightbulbit on these two DNS servers. So they will go on this DNS server and create a new zone called, no problems, was a lightbulbit. So once they create these new zones on these two DNS servers, they will now inform the people responsible for .uk. Remember what we were looking at earlier, right? There are people that are responsible for these servers. All of them, they have, if there's a document online where they'll tell you the person that is responsible for this one, you must have an administrator that we can send an email to. There is Nominate UK. So they will now contact Nominate UK and say, can you add a NS record to your .uk servers? And the NS record will be pointing to these two servers that we've created lightbulbit zones on. I'm not sure if that is clear. Is that clear at all?
Yes, that's clear.
Taiwo, what do you think? And Vin, what do you think?
Yeah.
Is that clear? Taiwo, is that clear?
They created not just an A record to use, they created a
Zone.
whole zone.
Yeah, so they go to the servers and they create zones for lightbulbit. Then they now inform .uk and say, update your database for NS records for lightbulbit. So what I can do is so they call it, there's a term that they call it because GoDaddy is not actually like hosting like any of these .uk servers. They only call, what they call people like GoDaddy, they call them internet registrars. So they're just registrars. That's all they are doing. They're just registering something. So they have these servers. So once they create this, they now inform the people responsible for .uk and say, create NS records for these two servers. What I can do is I can go inside my GoDaddy management and say, okay, I want to change these servers to my own servers. And say, I don't want to be using GoDaddy servers. I want to change this to custom and create my own servers and all that kind of stuff. So once I do that, what GoDaddy will now do is they will go on their servers, they will delete these two zones, and they will inform .uk and say, this guy has changed the name server record for lightbulbit to his own servers. So can you please update your record to point to this guy's servers now? I'm not sure. Do you get the point? Taiwo, is that clear?
Yeah, it's clear. It's
Yeah.
clear.
So that's exactly what so the whole thing, it's like a registration process. That's all it is. They have registrars and have administrators and have emails that they send to. And actually, there's like a form. I saw the form online the other day. The kind of form that GoDaddy will fill and send to .uk and say, this is the new record. And there's like, I saw there's like a place where you can actually see the amount of records that's been registered daily, like millions or something like that. And you can actually see the type of forms that they fill to register these things. So these things are not, they are not, let's see, let's bring some stuff up. So we don't want it to be mysterious to us when we're seeing these things. Like if you go here, you have, okay, ICANN accredited registrars. So I think so GoDaddy should be here somewhere. So these are the accredited registrars from ICANN. So these are the people you can go to and say, hey, can you register, a name for me? And they can register. So if I go GoDaddy, here we go. So there's GoDaddy, there's, whatever one you want to use. There'll be very sign there. So these are called registrars. Their job is to register names. So once you do register the names, they will inform the people responsible and say they are the ones involved with the communication and say update your record to this one, and they will update their record on the servers around the world. So that's there. So we've beaten that horse to death, that one to death. Now we understand how that whole thing works. So let's move a step further. So in certain cases, there are different types of DNS servers that people can have. There's a particular special kind of DNS server called forwarders. What are forwarders? Anyone wants to go for that first?
Forwarders are, instead of using the root hints, it forwards your queries to a different server. So there's two types. There's conditional forwarders for a particular zone, and then there's forwarders which would be for all addresses.
Yeah, good one. Nice one. So yeah, does anyone else have anything to add to what Shami said? That's a wonderful answer. What are forwarders? What's the purpose of forwarders? Okay, in which situation will you use a forwarders, Ven? In which situation will you use a forwarder in an enterprise?
Yeah, normally you got your internal domain DNS space,
Yeah.
like test.local,
Yeah.
and your DNS server is responsible for all, or authoritative for the test.local domain.
Yeah.
And all the clients have this DNS server configured. And if this DNS server doesn't know the answer of the replies, he will use his standard forwarder to answer all the other questions of the clients, like yahoo.com or so. And in this case, you would use your internet service provider's DNS server as a forwarder.
Yeah, that's So what you're basically saying is, let's go forwarders. So what you're basically saying is I use forwarders in a situation where you have a separate domain that cannot be resolved via routing. Is that what you're referring to? So what you're saying is, if you have a separate domain that cannot be resolved via routing, you use a forwarder.
Yeah, could be. Perhaps you don't want to use root pins, perhaps. Yeah. So it could be a reason because of firewalls or so. Yeah.
Yeah, good one. Taibo, what about you? Like, in what situation do you think you use a forwarder in an enterprise? Or you want to use a forwarder?
I think one of the things is if, let's say, you have two domain names, or two domains, or maybe two organizations are merging, and you want to keep both names, you can put a forwarder in your own domain because they are communicating. So any request going to the other domain, that would that would take care of the request. Like you have, let's say Microsoft on Google, you can create a folder in your in Microsoft's domain. Like anyone that is requesting for, let's say, mail.google.com, rather than going through the whole Microsoft server routines, everything, it will just point direct to Google. I don't know if you get that. But I think I've seen something similar before where two companies merged
Yeah.
but they don't. I mean, so they had to create a forwarder
Yeah.
in each one. The company A
Yeah.
had a forwarder. So anyone that wants to get information from company B from
Yeah.
company A,
Yeah.
that's DNS that resolves that information.
Yeah. That's absolutely. I mean, all the things that you've said, those are absolutely 100% correct. One of the main reasons why some people decide to use forwarders, one of the main reasons is some people, not everyone, is for security reasons. They'll say. And basically, what they mean by for security reason is this. They're like, yeah, we don't want our internal DNS server, which is typically for many organizations, they are domain controllers. Like, yeah, we don't want our internal DNS servers to be going out to be talking to the routing servers and going out directly on the internet. So what we'll do is we'll have a forwarder in here. So any record, any query that our DNS server cannot resolve, we don't want you to go talk to the internet directly. Just send it to this forwarder guy, which is basically another DNS server. This forwarder guy, which will probably be in the DMZ, we now go talk to routint and .com and .co and do all that stuff. But we don't want you to be going out to be doing all this stuff. So that's one reason why people would do something like that. Some people for security reason or maybe for performance reason, they're like, yeah, you're busy talking to .com instead of resolving internal domain queries. So if you can resolve internal domain queries, internal DNS queries, resolve them. But if not, send them to this forwarder guy who is dedicated for the purpose of resolving external external name resolution. And that's like what this guy is dedicated to do. So that's like one reason. And like what Shami mentioned, really, really good point in terms of there are two types of forwarders. There's the standard forwarders, which is basically the one that we just described now. So which is basically you have another DNS server in your environment. The other DNS server, you just configure it to say, hey, it has routint information on it. This one, you just configure it and say, talk to this DNS forwarder. So anything that is external, I'll pass it to this guy. This guy will resolve it on the internet, come back and pass it back to me. So I'm not doing like all the processing and all that. So that is just standard forwarding. Then there's the other one, which is conditional forwarding. And conditional forwarding is the one that Sven and Taiwo described, which is if you have a separate domain, it could be that you're merging with another company or you have another internal separate domain that cannot be resolved by routint, use a conditional forwarder. What do we mean by that? So maybe within this company here, that we're talking about, let's say let's make all this smaller so we have more white spot space. Small, come on. Yeah, get there. We'll make it smaller. Okay, yeah, here we go. So let's say this company, just like Taiwo said, merged with another company. And this other company is called, let's call it Taiwo's name. Let's say Taiwo.local is their own internal domain. So now you want to link these two domains together. But if computer one here wants to talk to computer one in Taiwo's domain, this guy will be like, it's like a request comes and says, I want to talk to, I want to talk to, I want to resolve client one dot Taiwo dot local. When it gets to DNS1 will go, hold on, Taiwo dot local, it's not on my server, it's not on me. That means it has to be on the internet. So what I'm going to do is I'm going to forward this query to the forwarder, or if I'm configured to go to the routint, I'm going to forward it to the routint and say, routint, I'm looking for cl1.iwo.local. And routint will go, huh? What are you talking about? you know, what's cl1.iwo.local? I know about .com.de.ac. I absolutely know nothing about .local. On a side note, very soon, .local may be registered as a top-level domain. Does anyone know about that? Do you know they'll be registered very soon? I think, yeah, from 2016, you may not, yeah, it's advisable from 2016 .local. So be careful when you're
Oh wow.
Yeah,
So many people will get a big problem, I think.
yeah. So Microsoft already registered top level domain. So from 2016, you can register any top level domain that you want to register. So yeah. So you can register any top level domains that you want to register. So be careful that you don't start using .local anymore. You see Microsoft recommendations. Yeah, .local. Yeah. Where is the yeah? But yeah, I was watching. There was a YouTube announcement where Ayana was making and where they said, hey, we're going to start registering these top level domain names, which may so anyone can register any top level domain name, which may include .local. So be careful. And from 2016, so let's see, 2016, it's got to be somewhere. Um, yeah, okay. Now is it this one? Yeah, let's see. Yeah. So that's something that so especially if you're like in a new domain, be careful not to use .local. Microsoft recommendation is you use a domain name, a subdomain of a domain name that you have on the internet. Okay, yeah. Yeah, this is it. It said what this means is that if you have a domain name that you use for internal network that does not appear in the official list of TLDs and is not registered to you, you will not be able to request a certificate from a public CA with an expiration date later than November 1, 2015. Most common use certificate expire every 2 years. So if you have a certificate issued by public CA that use a top level domain or name other than an officially registered name to be properly expired, for example, let's assume you are using internal domain name conducive.local. A public CA will not issue a certificate for any server in your conducive.local domain because the .local is not a registered top-level domain. Even if you're using conducive.com internally, where .com is clearly an official ID, you cannot obtain a certificate from a public CA because you do not own the domain conducive.com. Yeah, so just look it up online. So just be careful because from 2016, people can register any domain name. Did I just lose people? Hello? Hello. Hello. Can you hear me now? Hello? Hello? Can you hear me? Hello?
Oh, this is back now.
Hello. Yeah, sorry. Can you hear me now?
Yeah, we can.
Yeah, sorry. I lost my connection. My internet connection dropped off completely. Yeah, sorry. So I'm back now. Yeah. Okay. So actually, I think I found yeah, this one, but it's not just this one. I read like an official, and I not only just read an official documentation. I watched the Hyana video announcement where they announced this. So there's an awful lot of .local, .corp, .lan Active Directory domains out there. Da, 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 da. Um, da, 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 mm, da, 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 mm, da, da. Yeah, okay. It says, since this post was written, there has been a major new development with fabricated TLDs. The CA Browser Forum, which is a consortium of web browser vendors, public CAs has released a document titled Internal Server Names and IP Address Requirement for SSL. Guidance on the deprecation of internal server names and reserved IP addresses provided by SAFE can be found here. So this document says that no major certificate vendor will issue an SSL certificate for an address with a made-up TLD in it, such as .local, .lan, .corp. This echoes the best practices that have been published for years. So basically, don't use them in your domains, especially if you're going to be using something like public CA and all that. So just be careful with them. Microsoft's recommendation is maybe you register something like shami.com online, then use a subdomain of shami.com that you have registered as your internal domain name, maybe internal.shami.com or ad.shami.com. That's Microsoft's recommendation regarding that. So just beware of that. Okay, so as we're saying, your computer will go to routine and say, hey, I'm looking for cl1.iwo.local. Routine is going to say, I have no idea where this one is. Because this is not resolvable on the internet. It's resolvable because it's an internal domain. It's not something available on routines. It's an internal domain. So in that case, you use like a conditional forwarder where you can say to this one that anything that is .taiwo.local, this is the DNS server for it. So basically the way that works is if we go back to our server here, and let's log into this. I will go. The way that works is what we mentioned earlier is for the forwarder one, you can go properties and you can set the forwarder here for the standard forwarders. If you want conditional forwarders, it's right here. So basically what you just do is new conditional forwarder, and what you're saying is for domain taiwo.local, don't waste your time trying to go to routines because you won't find it. This is the IP address of the DNS server that you should send it to. So that's basically what you're saying. So you're just saying anything, any request, any DNS query that comes to you for taiwo.local, send it directly to this DNS server. This DNS server will know how to resolve it. So that's what conditional forwarder is. So you use conditional forwarder for if you have an internal domain, or a subdomain that is not resolvable on the internet, but you want your machines on your network to be able to resolve those names. You use a conditional forwarder. So there's something else that operates similarly to a conditional forwarder that we're supposed to talk about. Does anyone know what that is?
Stop zone.
Good, very good one. Stop zones. So Oze, what are stop zones?
A stub zone is a zone that just contains NS records and glue records, I think. And it's something like a conditional forwarder. It's just dynamic. So the NS records can change, and the conditional forwarder is somewhat static.
Nice one. Very nice point. Static. And say this one is dynamic. So there's something that operates similarly to conditional forwarder, which is stop zone. And there's always this question that is asked that which one should I use, conditional forwarder or stop zone? First, let's try to understand stop zone just a little bit. So this conditional forwarder, I can say taiwo.local. This is the IP address of the DNS server for taiwo.local. And if any request comes in for taiwo.local to my DNS server, it knows who to send it to. Or I can go here and say I want to create a new zone. And when it's asking me about which type of zone do you want, I can say stop zone. It says create a copy of a zone containing only name server, start of authority, and possibly glue host A records. A server containing a stop zone is not authoritative for that zone. So what it's basically saying, it will make a copy of just the important hosts of that zone on my computer. So if I go next, I can say to all DNS server zone name. If I say taiwo.local and go next, it's going to say what's the IP address of the DNS server for taiwo.local. I can type it in here and I go next and go. After I finish, what my computer will now have is it will have a small zone that contains the DNS server for taiwo.local. So if anything comes in and says, hey, I'm looking for taiwo.local, it's going to say, yeah, I have that record. So I'm just going to forward you to that DNS server. So it's somewhat similar to conditional forwarders. But what are the main differences? Sven mentioned something. Sven mentioned stop zone is somewhat dynamic. Forwarders is somewhat static. Can you expand on that a bit, Sven? What do you mean by dynamic static?
Yeah, you just configured the conditional forwarder. Perhaps we can look at the configuration again. I think then it would be very clear because you put in a domain name, right?
Yeah.
And you put in an IP address.
Yeah.
So when the IP address would change of the DNS server of the zone,
Yeah.
you would have to change your conditional forwarder.
Yeah.
But if you got a stub zone, you
Yeah.
can you also configure one NS server, but afterwards it gets all the NS servers that are responsible of the zones.
Yeah.
So there could be 5 or so.
Yeah.
And if one DNS server would change in the future, then your stub zone would be updated automatically.
Yeah. Nice one. So what Sven is saying in essence is you have conditional forwarder here set and say anything Taiwo.local, send it to DNS server 192.168.1.1. Now, if Taiwo, the administrator of this domain, decides I want to change my IP address to .1.4, this guy has absolutely no idea that something has changed. He'll still keep trying to send it to .1.1. So you have to go back manually under your conditional forwarder and say, actually, the IP address of the DNS server of Taiwo.local is now .1.4. That is conditional forwarder. But if you're using stop zone, it's going to be automatically updated because you have a little copy of the zone. So if the IP address changes, it will be automatically updated on your DNS server. You don't have to be manually maintaining it like that. Any other difference, Taiwo or Jose or Shami? Any other difference between conditional forward and stop zone? Any other difference? Shami, what do you think? Any other difference? Taiwo?
Nothing that I can think of.
Yeah. Shami, any other difference?
I was just thinking of the same answer Sven gave in terms of how it's updated automatically compared to the conditional forwarder.
Yeah.
I'm just trying to think if there's any other differences.
Yeah. There's another main difference. The other main difference, and Sven, any ideas? There's another main difference between them. Conditional forwarder, because that's a question that is really popular. That when do you use conditional forwarder? When do you use stop zones? Because their functions are similar. So in what other situation are they different, or when do you use this, the other one, and when do you use the other one?
I think that stub zones can also contain this glue record, but I have no idea what this glue record is, to be honest. Yeah. No idea.
Yeah.
Yeah.
So the other main difference is this. For conditional forwarder, you can use conditional forwarder with a company that it doesn't require I don't want to use the word authentication. It doesn't require permission.
Ah, good one.
Yeah.
Good one.
Doesn't require permission.
Yeah. For stub zone, you have to accept the replication. Yeah. Good point. Yeah.
So
right.
For example, I can use conditional forwarder for a company that I have no relationship with. A situation of that would be something like this. Now, I'm not. People don't typically do this in the real world, but let's say a situation like this. Let's say there are some companies that have like all this crazy domain structure. Like let's say marketing dot department dot company dot dot co dot UK. You have like all these complicated names, and basically, if your computer wants to resolve this, it has to go talk to .uk first. Then .uk will say go to .co, then it goes to .co. Then .co will say go to .company, then it goes to .company. Then down we say go to .department, then it goes to .department. Then it goes to .marketing. Then it does that. And of course, it's going to store it in its cache, as we mentioned earlier. But then after that, the cache expires, then it has to go through that process again. So what you can do is, if I know the DNS server that can resolve marketing.department.company.co.uk, I can add a conditional forwarder on my DNS and say, hey, rather than you going to routint to locate the DNS server for this company, this is the DNS server for this company. Don't go through all that process. I don't have to have a relationship with this company at all. The administrator doesn't need to accept anything. All I need to do is know the information of their DNS server, and I can just basically go, add it, and that's done. But for stop zone, the administrator at the other end of the other domain of taiwo.local has to accept what Sven said, replication has to give me permission to have a little copy of their zone on my own DNS server. So they need to give permission on their own DNS server for that. So that means your stop zone is used in a situation where you have a relationship with that company. Maybe a company that you're merging together with or something like that. But conditional forwarder, if there's a company that you don't have any relationship with, but you're like, hey, I know this DNS server that can resolve this one for this domain, I can use conditional forwarder for that. Is that clear at all, guys?
Yeah, that's clear.
Yep. Okay. So let's move a step further. I don't think we're able to do VPN and routing today. But yeah, let's see all the things they want us to cover. We've covered DNS namespace, where we talked about the hierarchical namespace starting from .root on the internet all the way down. We've talked about the people responsible for that, how DNS works on the internet. It's not something mysterious. We've talked about how querying works from top to the bottom. We've talked about forwarders. We've talked about conditional forwarding. We've talked about stop zones. Yeah. And the next thing they actually want us to talk about zone transfers and aging and scavenging. And so let's just talk about that and just call it a day. We have 11 more minutes and then we're done. Okay. Yeah. So in Active Directory, there are different types of Active Directory zones. What types of Active Directory zones? Actually, before we go there, let's just quickly mention something that Taiwo mentioned at the beginning. Remember something that Taiwo mentioned about recursive or iterative?
Yeah.
Yeah. Okay. So does someone want to explain what's the difference between recursive and iterative?
Well, wait a minute. Yeah, I think iterative is the one that it has the information and it gives it to you. While recursive is the one that it searches, it tries to find the information for you.
So let me write that down. So iterative has the information.
Yes, in its cache, and it will give it to you. But because it's authoritative it has the information in its record and it's authoritative. But
You said recursive does what? Tries to
does
find
not
it
have
for
the
you.
information. It has to make research the information.
Yeah.
Do research. Can I use that word?
Does anyone want to add anything to what I said, or does anyone agree with what I said? Jose, what do you think? Recursive, iterative? What do you think?
Sorry, it was on mute.
No, it's all right.
Recursive, recursive, I guess, goes out to the internet, to the DNS server, versus iterative, which searches your local DNS server.
Well, I think recursive is that what a client does. So the client does just ask his DNS server and says, okay, I have a question for you. What's the IP address of yahoo.com, for example? And then the DNS server does an iterative query and says, okay, hello, root server, I got a question for you. What's the IP address of yahoo.com? And the root server answers with, well, I don't have the answer for you, but I got the name servers of the .com domain, and then the DNS server will repeat this iterative query so long until he gets the final answer, and this answer is returned to the client.
Yeah, nice one. So so what Sven described is absolutely correct. Shami, do you have anything that you want to add?
The other thing is with the recursive queries from the client machine requesting an answer, and then it stores it in its cache. So if it then searches for that query again, it will when it looks in its cache as a recursive response.
Yeah. So absolutely, this is absolutely correct. This is absolutely correct. So recursive query is what the client does. So just think of, whenever you think of recursive, think of it this way. It has to receive a yes or no answer. So that basically, if you think of the situation I will describe there, if client one asks is DNS server, so like what Sven said, a recursive query is what the client does to a server. So you have this DNS, this your client computer here speaking to this DNS server. So it's not expecting this DNS server to come back and say, I don't know the answer, you go ask this guy. No, it's the answer it's expecting is, here's the answer, sorry, I can't find it, it doesn't exist. So it just wants a yes or no answer. That's a recursive query. I can't find it, I can find it, this is it. Iterative is what the DNS server does to other DNS servers. So it goes to ask root, and root says, well, I don't know where www.yahoo is, but I know where .com is. So even though I don't have Yahoo, here's .com. So it goes to .com says, well, I'm not sure where, www or what the IP address is, but I know where Yahoo is. Here's the IP address for Yahoo. So iterative is, I'll give you what I know. Recursive is, I just want yes or no. I don't tell me to go hack someone else. This DNS server will not tell this client, go talk to someone else. Whereas iterative will tell you, hey, go talk to someone else. I'll give you the information I have, go talk to someone else. Is that clear at all? Is that?
Yeah.
Yeah. So recursive is what the client does. It's like, I want the yes or no answer. Don't tell me to go ask someone else. The DNS server, when it's talking to our DNS server, that's iterative, where it says, hey, I don't have the answer. I don't have the full answer, but I have .com answer for you. So go ask .com. So that's the other part of it. So that's for that. And then there's another one about talking about authoritative and non-authoritative. What does that mean by authoritative and non-authoritative?
Authoritative is when it is the DNS server for that domain, and non-authoritative is when it passes it on.
Yep. So authoritative is how did you call it again?
When it is the DNS server for the domain that the query was run for.
That the query was run for. And what about non-authoritative?
Is when it is not, and it passes the information on to somewhere else, or it might have a response back from a forwarder, for example. So maybe your ISP, and that would be non-authoritative.
Yeah. So yeah. And Sven or Taiwo, you want to add something else?
No, no, not at all.
Yeah.
I know authoritative is because it manages the domain, so it knows the information.
Mm-hmm.
Yeah, that's it. Yeah.
Manages the domain, so knows the information. Excellent. Excellent. Ray, you want to add anything?
A non-authoritative server could be non-primary server, a server who just is a secondary server. So it just has a copy of the DNS database, but he doesn't he's not allowed to do any updates on the zone. Is that right?
So you're describing the secondary server. But a secondary server doesn't mean it's non-authoritative. A secondary server can be authoritative. Authoritative simply means what Taiwo and Shami described, which is basically I'm the one hosting the records for this zone. So I have a DNS server here. This DNS server is hosting the record for a zone. So I go yeah. So this DNS server is hosting the record for clc.co.uk. So if any request comes for clc.co.uk, this server goes, I am authoritative for this zone. I'll give you an authoritative response. This zone exists on me. So the response I give you is authoritative. If you ask this server and say, hey, can you tell me what's the IP address for, django.clc.co.uk? It's like, I can tell you authoritatively there's no django.clc.co.uk. It doesn't exist. The way I can tell you authoritatively is because this zone is on me. I host this zone. So it could be secondary, it could be primary, it doesn't matter. As long as I host this zone, I can give you an authoritative answer. So
Okay,
in like the
but when you got an secondary server,
yeah.
it gives an answer. I think it's not authoritative because perhaps there are updates on the primary server,
Mhm.
and perhaps the secondary server doesn't know about these updates because these updates are not replicated yet. So I thought that this server could not be an authoritative server, but perhaps I'm wrong.
What do you yeah,
I'm not
Shami,
I'm not quite sure about this.
Taiwo, what's your thought on that, or Shami? So do you think a secondary server is an authoritative server for a zone? So if I'm a secondary server for this zone, so a secondary server is just a server that hosts a copy of the zone record. So you can't update the zone records on me, but whatever you update on the primary are replicated to me. So that's a secondary, but you cannot make the changes on me. So do you think that is authoritative for that zone, or do you think it's non-authoritative for that zone? A secondary server.
Well, well, I think it's authoritative because whatever happens in the primary
Mm.
gets updated in the secondary. So the information is still up to date.
But it just will replicate to the secondary server if notifies are enabled. And if there are no notifies enabled, the database doesn't have to be synced.
What do you think, Shami?
Sorry guys, I was on mute. Yeah, so I would agree with Tyro with that because it has all the records, it is up to date, and it has the zone with inside it, then yes, it would be authoritative.
Yeah. I'm not.
Okay, I will just check in my lab environment. Wait for a second.
Yeah. Okay. Well, this is just a user answer. This is not an authoritative answer. He said a secondary content server is as authoritative as a primary one. Let's see something that is much more reliable than this. So I'll also say that I'll also agree with Taiwan with Shami that it is authoritative. But where let's see. Um, Okay, look at this. He said the term authoritative refers to any DNS server that has a complete copy of the domain information, whether it was entered by an administrator or transferred from a primary server. Thus, a secondary server can and should be authoritative for any domain for which it performs secondary authoritative resolution. So yeah, it is authoritative. So secondary servers are also authoritative for that zone. Because authoritative just means, hey, I have the copy of the zone. I have a copy on me. So whether it was entered by an administrator or transferred from a primary server or transferred from a primary server, it doesn't matter. Yeah, so it is authoritative. Yeah. So like in the situation that we're talking about here, so in a situation where a request comes to this DNS server for yahoo.com and then it goes to ask the root server, and then root server say ask.com, and then it goes to ask.com, then eventually it comes to ask Yahoo, and Yahoo says, yeah, I know the IP address for that, and replies. So this DNS server will now pass that reply to the client, but the reply that's going to pass to the client will be non-authoritative, because we'll be like, hey, here's the IP address for yahoo.com, but this reply is not authoritative because I don't host it. Another DNS server told it to me. So that is non-authoritative. So if I go NS, yeah, so that's my server that's giving me the response, and it's going to be saying to me, I'm giving you this answer, but it is not from me. It's coming from someone else. Someone else told me this response, so it's non-authoritative answer. So that's what it means. So I think this is where we have to end for today, guys, because we're out of time. We still have little bit of DNS to complete, and then we have VPN and routing and direct access. So I think we'll try to cover all those three together next week. But I think we'll stop here for today. I think it's been a good hangout so far. What do you think? Did you get anything from today's hangout? Was it helpful at all?
Yeah,
Yeah.
yeah.
Yeah. Nice
But
one.
we haven't talked about replication and scavenging and stuff like that.
Yeah.
But it's okay. It's
Yeah.
okay.
Yeah. So those are the ones that we have left. We have, like you said, replication, zone transfer, and we have scavenging left.
Yeah, and
So yeah.
time to live and stuff like that.
Yeah. So after that, we're done with DNS for 7411. Then the next one is
Yeah.
VPN and routing. Then after that is direct access. So we'll try to cover those three next week.
Okay.
Just to
And
get
then
them.
I will also double check the stuff with the non-authoritative answer, because I'm quite sure that this is correct, but I will check until next
Yeah.
week.
Yeah.
So
Yeah. That'll be good. Yeah.
yeah, yeah.
Yeah, that'll be really good. Okay, nice hanging out with you guys. Thanks very much.
You too,
Okay.
guys. Thank
Have a
you.
wonderful
Bye.
week. Taiwo, we have a date. We have a date on Wednesday, right?
Yeah, Wednesday. Yeah, let me.
Sorry. What will be the topic next week?
Next week will be the ending of DNS, which is zone transfer, scavenging, and that. And then
Okay.
we'll
So
do
we
then,
just continue.
yeah,
Okay.
exactly. So and then we'll do VPN and routing. So VPN and routing is the next one, and then direct access. So those are
You
the
would do
three. Carry
you
on.
would do direct access as well
Yeah,
next week. Will
yeah.
you have enough time?
Yeah, it's part of, and we'll try to. We'll have to try to. So what I'll probably do is like the first 1 hour, I'll just try to cover routing. Well, I'm sorry, we'll just try to discuss, because it's a discussion. We'll try to discuss routing and the remaining DNS. The remaining DNS shouldn't take us more than 15 minutes to discuss. VPN and routing will mainly be covering just the main point, because normally, actually, like although there's a lot to discuss with VPN and routing, there's lots of VPN protocols to discuss. Because I looked at the syllabus, I have the syllabus in front of me here. It's a huge syllabus of VPN and routing. Actually, what we'll just do is we'll just see how far we can go. We'll try to discuss direct access next week, but we'll see how far we can go. Because VPN and routing is also like it has huge information. We have to discuss all the VPN protocols. We have to discuss all the encryption protocols that they use. We have to discuss the authentication protocols that they use. So
That's why I was thinking,
yeah,
how will we have enough time?
for direct access, yeah, it's true. We'll see how far we can go. We'll see. So it depends. So
Okay.
if we try to read ahead also, because that also makes it like way much faster. If we try to read ahead, because we just discuss it, boom, 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 we discuss it, we make sure that everybody's on the same page. So once we're all on the same page, we can go much faster. We can go, yeah, we got this one, we got this one, we got this one, we got this one. Let's move on to the next one. So yeah, we're making progress. 7411 is just a lot more material to cover than 7410.
Yeah, absolutely. Absolutely.
Yeah. Okay. No problem, guys. So nice hanging out with you. So see you
Take care.
next time. Wonderful.
Bye,
Okay.
guys.
Yeah.
Thank you.
Thank
Yeah.
you all.
Yeah.
Okay.
Cheers.
See
Bye-bye.
you next week. Bye.